All right, so at this point, we've graphed trig functions. Now, we're going to imagine we're given a trig function, and we have to come up with an equation for it. So the process in that is very specific. What I like to always do before writing the equation is look at a couple of things. I want to figure out these characteristics about my graph, looking at it. So first of all, I'm going to look at my graph and look at the axes and look at how they're scaled. And so I'm noticing that the increments on my x-axis are increasing by the angles that are there every pi over 6 units. So that's important detail. I can only see the negative side of my y-axis, which is fine because that's where the majority of my graph sits, and it's all the negative angles. And then I can see a midline, which is drawn at -2. So I'm just going to go ahead and acknowledge that as I see it. Next is that I got the midline. I probably want to know what the amplitude is, so I'm kind of measuring out my distance here. So pretty much I want to know, in particular, how far is the midline to the max and the max to the midline. Essentially, that's what I want to know. Those two distances should be exactly the same. And they are 1 unit apart. So my amplitude is 1. Finally, the period. Now this is how I'm going to discover two things. By looking at this period, it gives me a sense of how I'm actually going to look at this graph, if I'm really viewing it as a sine curve or a cosine graph. Okay. Now, it depends on what point that you want to start from. As I look at this, I notice that the midline is at y equals -2, and I notice that this point right here in particular that I'm going to highlight with a point at 0, -2 is significant. Why? Because I know that sine normally starts at the midline. Okay. And I know that if it were no transformations, this graph would be starting at 0, 0, right? There were no transformations, but there are transformations clearly. The midline's at -2. I can create a sine graph out of this, but the problem would be if I continue to my right, I'm not really certain at where it would end. I could probably take an educated guess, but I don't want to guess. I want to know for certain where this graph is going to end. So I could potentially start at 0, 2. I'm going to save that for a moment. There's another spot you can start at to determine where your graph will end, and that you get a total of 5 points you can actually see on your sine graph. So I'm going to move a point here on the far left, which is at -pi/3, -2. Now, if I start from here, let's see if I map out 5 points like I normally would on any sine graph. So there's 1, 2, this is 3, this would be 4, and then this would be my 5th point. Okay, now this is definitely coming out to look like a sine graph, but what's the period? Well, here's how I would determine the period. I can clearly see that the graph starts at -pi/3 and ends at pi/3. So if I determine the difference of those two angles, starting with pi/3 minus -pi/3, this will tell me exactly where my period lies on this graph. Now, this pi/3 minus -pi/3 is the same as basically saying pi/3 plus itself. Negative times a negative is a positive. Great. So that means that pi/3 plus pi/3, or 1/3 pi plus 1/3 pi, is 2/3 pi. That means that my period is 2/3. Great. Now that's going to help me find something else that I need. In order to write the equation, I need the C value, right? Because if you think about this in terms of transformations, there's an A, there's a C, there's a H, there's a K. In most cases, not all cases, but most cases. The C value is important because it's the coefficient to the X that you're going to put in your equation, the input. So how do you get the C value? Well, here's what I know. I know that the period is 2 pi over 3. I know the formula to find the period is 2 pi over C. Now, as I look at this proportion, this is very balanced and equal. The numerators are both equal to 2 pi, so it only implies that the denominators have to be equal to, which means C has to equal 3, which is perfect. It's perfect because now I can write my equation because I have my other components here. Now remember, you are basing your equation off of this model. Y equals A, we're going to go with a sine equation, C times X minus H, remember H is your phase shift, your horizontal translation, plus K. Now, here's where we have to note. If we're going to start from this point, negative pi over 3 comma negative 2, and I'm going to write that here again. Gotta pause it. Get my pen together. Give me a second, friends. My equation, if I started at negative pi over 3 comma negative 2, will be negative A. Let me explain quickly why. My amplitude was 1, but my sine graph starts at the midline or a middle point and moves downward. A normal sine graph starts at the midline and goes up. If I notice that it starts going down from the middle point, the first middle point, I have to incorporate a negative A value or a negative amplitude for that in my equation. So that's why I'm writing negative 1 there. Sine, our C value was 3. There is no phase shift, so I'm going to write this as 3x. If you want to put that in parentheses, you're welcome to do that. Not required, but you can. Plus K, we found was negative 2. So minus 2. So at this point, this would be my trig function. Negative sine 3x minus 2. If I chose to start at the first point that I indicated, which was at 0, negative 2, this is how my function would change. I could still map out 5 points if I extend this graph further right, but starting from 0, 2, a middle point on the midline, the graph is moving upward, which is great because that's how I'm used to seeing a sine graph move anyway. So it would be 1 sine of 3x minus 2. Okay. Now, just to keep it interesting, we can write a cosine graph for this as well. But with a cosine graph, that comes with a phase shift. Okay. Now, remember, phase shift is a horizontal translation, either h units left or h units right. You have to know traditionally where a cosine graph starts from. It typically starts at a maximum point somewhere on the y-axis. Now, the closest point that it could have started at if it were on the y-axis would be at this point right here at 0, negative 1. The closest point to 0, negative 1 is this point right here, which is at pi over 6, negative 1. To get there, I had to move pi over 6 units to the right in a positive direction. That will represent my phase shift for a cosine curve, right? Because you see this is a maximum point, and the graph would just continue in that path and give me a cosine shape. So I'm going to write this next. If I start at this point as a cosine graph, it would look like this. 1 cosine of 3 parentheses x minus pi over 6, because remember I translated to the right, pi over 6 units, minus 2. Sometimes people use double grouping symbols around the 3 times x minus pi over 6. You can do that. I'm not going to write it. It's not really necessary, but it's fine if you did. It wouldn't be harmful. But that would be my cosine equation for this graph. And if I were to put all 3 of these in my calculator to sketch the graph, all 3 graphs will overlap each other. And that's how I would know the graphs are the same. Okay? And that is how you write equations for trig functions.